Welcome to today's session on artificial intelligence and machine learning. It is session 3. So in our last session we have covered Python language fundamentals and some concepts, important concepts. So in this session we are going to learn some more concepts on Python. So I think we have stopped at mutable and immutable. I just gave the definition. However, I did not explain with an example. So from there on, we are going to continue today. Let me quickly share my screen. Okay. So yeah. So let me reiterate. Okay, what is mutable? What is mutable? This is also important in C language and all. We don't see this concept, but in Python, this concept comes into picture. Okay, so what is mutable? The value can be changed. Okay, in that particular memory location or something object, if the values can be changed, then we call that as mutable. If the values cannot be changed, we call that as immutable. So for example, yeah, see, and I mean, first of all, what all the data types that are mutable? Okay, if you remember, then what all things are immutable, you can remember easily. So list, okay, tuple and dictionary. These are mutable. And immutable. Integer, remaining things. Okay, integer, float, and everything like.
Sir, is Boolean also immutable, no, sir? But
Boolean
it's
also yes, immutable. So that is why once you see the understand the concept and you understand the program, then you don't need to like memorize certain thing. It will come automatically. I will explain. Yeah, Boolean is also immutable. So string Boolean sets. So these are 5 plus 3. Okay. And another thing is non-data type. Uh, I mean, I don't know. I did not gone through that whether non-data type is mutable or immutable. Because none means basically I don't think it occupies memory. I don't. Okay. We will see that if required. But for now, these three are mutable and these are immutable. Now, what is the underlying concept? For example, a particular a equal to 5. Okay. Now, when I am again writing a equal to 3, how does Python uh, internally handles this? How does Python internally handles? So, for example, it assigns one memory location and 5, and a is pointed to this one initially at this step. Now, when you are changing a equal to 3, so Python will create a separate memory location. Probably this one, this probably I explained in last time. So this memory location is at 1000. This is at 2000. Python will just change that pointer. Okay. Okay. Python will change that pointer from this to this. When you are changing from a equal to 5 to a equal to 3, Python will change that pointer from 5 to 3. However, the value 5 is not replaced with 3. Okay, so therefore, this is, immutable. You can, this value 5 is not replaced with some other value. However, in case of lists and all, because Python is, it is an object-oriented programming language. So, for example, if you take the list, for example, A equal to 1, 2, 3. Okay. Now, you can change it. Like, for example, if you say A of 0, 1, 2, okay, these indexes will be 0, 1, 2. That is the indexing. Hope you might have already aware of in C how
Yeah,
the
sir,
arrays
yeah,
work.
sir.
Similarly, list will work here. Now, if I take A of 0 equal to, or I would say 0, 1, 2, A of 2 equal to 4, then the list contents gets changed. Okay, that is why list is mutable. So let us quickly write a program. To see, for example, um, yeah, how will you verify this? For example, I will get, A equal to 5, then we are changing A equal to 3. Now you type the address. Okay, value is A, memory ID of A. Okay, the value 5
Sir,
is at,
sir, why we have kept A in flower brackets?
correct. So currently I have used the formatted strings. So whenever
Okay,
you are using formatted strings, the strings, all these things are kept in simple double quotes. If
okay,
some value, for example, here A is holding the value of 5 and you want to print that value, then if you,
okay.
without flower brackets, if you put A, just better to, understand the, uh, like negation. From negation, if you try to understand, if you put simple A, it will print just A value A, but it will not print 5.
Okay.
Okay. So if you want to print that particular value, then we will be using the flower bracket.
But I have previously how I will write means print value of A is I will close the double quotation both sides and keep comma, and after I will
Okay.
give A again, sir.
Correct.
Like that I
Say
will write.
yes. Okay. Let me write the print statement. What you have mentioned.
Yeah.
Value is A.
Yeah.
Memory is ID of A. So this is also valid. So yeah, that depends on each individual's comfort level. So
Okay.
I
So both
am
are same only, na
habituated.
sir?
Both are same. So
Okay.
I am habituated to this one. So
Okay.
I just use the formatted strings. See, both are same.
Yeah, sir.
Okay. Um, okay. Now, um, now let me again do this print statement and run this code. See, the value is 3 and yeah, value got changed, but however, it is the same A, the naming convention identifier is same. Here also A, here also A, but Python is assigning different address, okay, for that particular identifier.
Yes.
Now let us see the, so that is, therefore, this is immutable. The that particular address at the like for example, in case of here 464 at the end of 1568, in this particular address location 5, we cannot change it. Now let us see the example for list. So a equal to 1, 2, 3. So list is A, memory is ID of A. Now I am changing the value A of 2, 0, 1, 2 at the index location 2. I am changing from 3 to 4. Then again, I will take the, or probably we will do B. Just okay. Okay, I am changing. Sorry, actually I got the call right. Okay, see, it is the same memory 4364548416436. 4364548416416. It is the same memory, but the list contents 1 to 3 got changed to 1 to 4. So that it is a very important interview question. So that's why I am explaining with program.
Okay,
so the yeah, mutable means that values inside the data type can be changed. Immutable means the value of that particular data type at that particular memory location cannot be changed. Now, what is the difference between is and equal to? What is the difference between is and equal to? This is also important interview question. Simple only. So it is also same. The memory will be different. In case of equal to, it exactly checks the identical. So if both contents, the data type contents, if both are same, then if both are identical, then equal to will return true. If the both memory location is same, then this is will return true. So let me explain with an example. It becomes easy. So A equal to C equal to 5, then D equal to 5. Okay. So, but here most of the cases will get true, because what Python does, when you internally how the Python handles this situation. So 5, that particular value is I mean C is pointed to that particular value. When some new assignment you are doing, Python will map. So for example, C 5. So whenever you are trying to write then D equal to 5, Python will not create separate memory location, because that is how it handles. So it points out to the same 5. So therefore, in this case, you will get true only. So A is B, A, B. A, we have given A.
alphabet change.
Okay, so both values are identical and both are pointed to same memory location. If I give 15, then this 15 is a different value, and Python will create a separate memory location to hold that 15, and D is pointed to that 15. Then both are not identical. Okay, both 5 and 15 both are different. So, and both the addresses also will be different. So if you execute, you will get false, false, false. So, but it checks whether both are pointed to same memory location or not. Okay, is double equal to will check both values. I mean, C is one variable and D is one variable. Both values, variable means it contains some value. Both values are identical or not. Okay, that is what is equal to. Both
Yes.
values are equal or not. Yeah, you like remember this sentence, that would be sufficient. No.
Okay.
Here
Both values are.
both not identical, identical. Both values are at same memory location or not. Now, next thing is positional versus keyword arguments. There is different name also. So we can also call these positional arguments as labeled arguments. Not sorry, keyword arguments can also be called as labeled arguments. Positional arguments can also be called as default arguments. I will explain first of all. So I can explain through some program, but before going into the program, like you use functions. Probably even we have not yet reached that within language definition, we have not reached the functions and built-in methods and all. However, you might have already came across functions in C language, so that understanding will be sufficient to understand this. So, for example, you are passing some arguments. Okay. Let us take the example of registering a particular student. Okay. Uh, Registering a particular student. So, serial number equal to 1, comma, register. I am calling the function register. Serial number equal to 1, comma, name equal to Subhash. Okay, so you are calling this function, and in that function definition, this is function call. Hope you are if you, know all these things. Just I will. This is not. This is function call, but function definition you will write in the somewhere here. Okay, def register. What is def? That is just like we use void or int in case of C language and all. So in case of Python, def is a keyword to write the functions. Now def register, you will take these arguments, okay, serial number, comma, name, and you will store it and do the registration, whatever. So let me now take other scenario. Yeah, let me put this is a different scenario. Okay, whatever here writing below. Now again here also I am registering a particular student. RE register of 1, comma, Subhash, and I am writing the function definition. This is the function call. We are calling that particular function, and here I am defining the function. So I can take whatever name I can like. Okay. So what is the difference between here this one and this one. So the difference is here the arguments that I am passing, they are keywords. Even if you change name equal to Subhash here and serial number 1 here, it will still work. It will, Python will still handle it because, Python will understand. But here, if you pass one here, interchange, if you interchange the arguments, Python will not be able to understand because the positions got changed. Here, the position is first argument, second argument, third argument, fourth argument, like that. Whatever number of arguments you pass while calling the function. Now, whenever you are using the register, whenever you are writing like this, if the position gets changed, then Python will not be able to understand and you will get an error when you run the program. However, when you are calling the function like this, these are keyword arguments. These are keyword arguments. These are positional arguments. And another term, these are labeled arguments that I have put in the next slide. So these are labeled because we are labeling it. We are labeling Subhash is a name. 1 is a serial number. We are labeling it. So these are called as labeled arguments. But here these are called as default arguments. Is in case of keyword arguments, even the positions are changed. Even the positions are interchanged. Python will still understand and handle it. But in case of positional arguments, if you interchange the positions, Python will get confused and it will throw you an error. Okay, that is positional arguments versus keyword arguments. We are not writing program for this. We are writing here. Actually, these are important. This is important, and like you can test it out whenever you get some free time. You can interchange the positions, and it will throw you error. Okay, that is position versus keyword arguments. Now, args, quarks. So this is very important, even in interviews and also when you are writing the code. Basically, the full form of is args means arguments and quarks means keyword arguments. Okay, args full form is argument and quarks full form is keyword arguments. So here just now you heard that keyword, right? So then what is this args quarks? Let me give some basic understanding, then we will write the program. Okay, so now again I will write one function. So in this case, I think I can use a simple. Okay, fine. Yeah. So I am now calling one function here. Add 1, 2, 3. Okay, and the output is result, res, and print result. We will write the program, but some things are needs to be explained by writing and all. So here you are defining this function. Okay, def add star args column, and for adding what we have to, how will you add this 1, 2, 3, right? It is a I will put sum of sum is a built-in function, just like we have. I have highlighted in high level in previous session probably, just like print and input. These are built-in functions. Similarly, sum, min, max, and there are reverse. reverse something. So these are built-in functions in Python. So I am using sum of args. Okay. So however, then I mean we already have these arguments. Why you are using this star and all. So basically, how does Python handle this? Python will internally it will first of all when you have sending 1 2 3, okay, it will pack those arguments. Uh, you will understand slowly. Packing, unpacking, that is also a concept behind this underlying concept. Let us first understand the way it behaves. 1 2 3, you are passing 3 arguments. Then this thing, first of all, it will pack those arguments. Okay. Uh, I mean, like, see, packing those arguments, don't think it is some. See here, 1 2 3, these are, I mean, different values at different locations, right? So these are first of all packed and slow one by one. Like for example, 1 2 3. Now one by one it will gives input to this function, and this function will, I mean, return a tuple. Shouldn't use the word return because return is this one is the final return. But however, it will prepare one tuple. In case of args, it will prepare the tuple. In case of quarks, it will prepare the dictionary. So when you are sending 1 2 3, so it will prepare one tuple, and then it will add the contents of the tuple, sum of args, and it will return and it will print the result. So you can also, I mean, check this one here for your reference. If you want, you can check. Like you can write print of type of args. It will be tuple. So let us quickly write the program and we will see if you have any questions.
Okay, sir.
So yeah, the program is args. So add 1 2 3 is equal to print res. So I have, this is the function call, but I have to define that function. And I have to return the sum. Before returning, I will just I explain the concept. So I want to see in a practical way. Okay. And for you yourself know you have given past 3 arguments, so you can just return args of 0 plus args of 1 plus args of 2. Some built-in function did not work for tuple. We will see that later. Okay, sum of these things is 6. If you do not know the number of arguments that you are passing, then we will take that number and we will loop. We will iterate those arguments and we will find out the sum. So basically, few points only we have to highlight. It will pack those arguments and it will give those arguments to the function, and the function will prepare the tuple in case of arguments. Once tuple is prepared, then I mean, whatever way you want to code it, you can code it. Like for example, 1 2 3, you want the sum, so I just added it in the return statement. Now, in case of keyword arguments, the return type will be dictionary. So let me write the quarks also. For quarks, you have to use two asterisk, like two stars you have to use here. Okay. Okay. So for quarks, what example should we take? Um, Register, because it is a keyword arguments. So yeah, same register. You are registering a person, and you are passing serial number 1, name Subhash. Okay. Then reg equal to and print reg. Now, but with this space, if we go, syllabus will not be covered. So def register serial number and name. Okay. First quarks, then this error is coming because we have not here it you see the red underline. So whenever that red underline you have seen immediately, like you should know that there is some error in the program. Why? Because the returning you are not returning here. This function is incomplete. Python will not be able to understand. You are not returning anything to this function, and this will not understand here. So you can check this one type of quarks, and you can uh, return what you are returning. Yeah, let us check this one of 0 and so 1. But if 2 are returned, it won't be able to handle here. So serial number 1, name Subhash. Let us print here. Okay, let us print here only. Uh, if I did I mention any program here? Quarks we can write. Okay, write a function employee info that accepts employee details, name, ID, department, print them nicely. Instead of name, ID, department, I am taking serial number and name. Okay, you have to print them. Okay, so I will just print them. Print name is quarks of 1. Serial number is okay. Serial number is quarks of 0. Okay. Now why still it is showing here error? Okay. So hope you understood where we
Yeah, sir.
went wrong. Now, yeah, name is Subhash, serial number is 1. Okay, the class is dictionary. As I explained, this serial number and name, you are passing two keyword arguments, and these quarks will pack those two arguments, and it will supply those two to the function, register function, and register will prepare one dictionary from these keyword arguments. Okay, if you print directly this, you will see the dictionary. You print directly quarks, you will see the dictionary. See class dict, this is the dictionary, serial number 1 and name is Subhash. Okay, no need, I mean, any doubts you can ask, else you can, I mean, practice this program, the same program again, and then you will get the strength to write the new program also. Okay, so um, coming to the next thing, this is the args quarks, arguments and keyword arguments. Now coming to lambda functions. Okay, lambda function is an anonymous function which you can write without using def keyword. Def keyword is used for functions in Python. However, without def and using the lambda keyword, you can write it and it is an anonymous function, and in a simple way you can like, and also it is in one line you can write that function. Okay, yeah, where it will be helpful in the real time use cases. First of all, let us understand lambda, because yeah, there are so many concepts out there, you might get doubt like so no need to worry. Okay, lambda functions. The syntax for lambda is like this: lambda and arguments and a column expression. And whatever you are returning this lambda function, you can write here result in the result. So this is the syntax for, actually I am wrong here. 1 minute. So lambda arguments column expression and okay, this will not be ternary. Yeah, correct. Okay, we will see if things are meeting. So I don't think. Yeah. So first of all, the syntax for lambda, it is like this: lambda arguments column expression. Okay. For example, here itself I have mentioned one example. We will write out that program. What is that thing? Square of a number. Okay, write a lambda function that returns the square of a given number. How will we write this one? Okay, lambda x colon arguments colon expression x into x. Okay, now the result you are putting here. Maybe I'm going fast. Let me take time and explain. So whatever result you are putting here, but the lambda syntax is arguments colon expression. In normal functions, you will write like this: def function name, for example, square or whatever. Here you will write the arguments. Here you will write the arguments. So here these arguments are these only. Both are same. Both are same. And this expression is something what you write inside this here. Inside you are writing some code. Okay, the function code. So that expression is same as this expression. So nothing to work hard to remembering this syntax also. Okay, now let us write that answer. So I am passing print of. Let us look at the original functions, then we will understand the lambda, it becomes easy. So original program, you will write like this. You will write like this: return x square, 5 square, power 2, right? Okay, you will write like this and you will call like this: print of square of 5. Okay, you will call like this. Let me comment this lambda 1. Now let me execute this one. 5 power 2. What it does? It is giving 7. Okay, no issue. X into x square. Okay, so this is how we will write the normal function. Now from this you try to understand the lambda. Okay, for example, okay, lambda x into x. So this is the extra keyword that we are getting. The function name is square and the lambda function name is also EL square. So simple. This def will be replaced here with lambda and remaining this is argument. This is argument. Okay. Arguments and expression. You just remember this one. Okay. And whatever name you can give, whatever name, and you can call it here. So this is the declaration part and this is the calling part. Okay, hope you are clear now. Any doubts you can pause and ask me. But this is the original function, I mean, which we write. And using lambdas, you can simplify it and you can, like in a single line, you can write the code. Now the syntax for lambda is lambda space argument space colon this one. Now let us quickly, what if you have multiple arguments? For example, you want to multiply three numbers. Okay, square of 1 comma 2 comma not square multiply of, let me not disturb this one. Now print of multiply of 1 comma 2 comma 3. What if you have multiple arguments? Okay, then how you have to define this lambda? Lambda space whatever names you give, I mean arguments you can name anyway, a, b, c or x, y, z or whatever. Here x into y into z. Okay, now it will become 6. So this is multiplication. So if you have multiple arguments you are passing, then you have to, in the syntax, you have to mention multiple arguments here, multiple arguments here. So, and whatever way you want to write the function, you write in the expression here. So this is the function definition and this is the function call. So this here is the name. Okay, I have already shown you the original function how we write, and from this you try to understand the lambda, it becomes easy. So that is lambda functions. Now comes enumerate. Enumerate, so these things it will help in real time. For example, this lambda in real time, how it will help. Whenever you are using the higher order functions, whenever you are using the higher order functions, like for example, sort or sorted. Okay, so whenever you are using the higher order, because these are higher order, these are built-in functions. Like for example, here also, this multiply is one function, which is a user-defined function. You have written lambda function, but this print has the higher order. So similar way, whenever you are using the higher order functions, then this lambda will really, I mean, be effective in real time. That example I have not mentioned here. However, you can practice it. Okay, you can practice it. Lambda example 2. So for example, the employee list is like this. Okay, employee list is, we will use list or dictionary. Which one? We will use dictionary. Okay, name. Okay, scores. We will take the scores. Okay, student scores. Student scores. Subhash. Okay, 75. Okay. Next, Chandra 65. Next, Ram 100. Okay. So now I want to sort these scores. 65 is lowest score, 75 is next highest, and 100 is the highest score. So you want to sort these scores. In this case, this lambda will really help. So how will we use the, how will we, uh, 1 minute. Yeah, how will we use the lambda here? Mm, okay, first we have to call the function, right? Um, yeah, in this case, sorted off. These are all students. So, and you have to student scores. You have to pass this one, student scores. Okay, so this is the student data, student 75, and this is the Chandra 65, Ram 100. Now we need to sort the data. Okay, let us say now this what the sorted is also built-in function of Python. Now we are passing this sorted data to this one, and this one is the our lambda function. So these things are will come by practice. For now, you don't need to worry. Now let us assume taking the example of the building. Immediately, if you see 100 floors and all, oh my God, this much tall. But nonetheless, you go step by step, then things becomes easy. You don't need to get panicked, like whether will I be able to write the code or not. So here, this is the lambda function. I am using lambda for, I mean, from this, it will take the x of 1. So here, see, by default, this sorted function will pass one argument at a time. Okay. First, I will explain this program quickly. Try to be more attentive. This student data we have passed here. Now what sorted will do, from all these three items, it will pass one item at a time. So in the first iteration, X will have Subhash 75. Okay, 75. And in the next iteration, X will have Chandra 65. Next iteration, it will have Ram 100. So in that way, I mean, this is a built-in function. So I mean, internally, all the details becomes difficult. So in that way, so first x becomes 1, and the lambda function, the expression that you have written is x of 1 means 75. Okay, if you give x of 0, it is the Subhash. So you will not get the. Okay, let me execute both, then it becomes easy. I don't know whether this sorted will sort the names as per alphabetical order. Yeah, see A, B, C, and A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, R, and then S. So C, R, S is sorted by names. x of 0. And here if I give x of 1, it will sort out by marks 65, 75, 100. Okay. So the point is, whenever you are using lambda, the syntax is very simple, but the real world scenario is when you use it as a subordinate to higher order functions. So this sorted is some higher order function, and this lambda is also a like one line function. I mean Python lambda function. So when you are using this lambda as subordinate to a higher order function, then that will be a real world scenario. It will help in real time to, I mean, write a quick and efficient code. Okay. So you need to practice a lot. So hope you understood from the examples that I am giving. So it requires a lot of practice. Okay, now comes enumerate. I think next one is, yeah, next thing is enumerate. So enumerate is something, it will add a counter to a particular iterable. Okay, let me explain. For example, list is one iterable. Okay, list is one iterable. Subhash, Chandra. Let me take two only. Let's not worry. So this is a iterable. Why we call it as iterable? Because it can loop. You can loop that particular argument, that particular one. So um, you can loop this particular uh, list object. So that is why we also call it as iterable. Now enumerate. Enumerate is something, it will add the counter to that particular iterable. Means, for example, 0 Subhash, 1 Chandra. Like that, it will add the indexing, or I mean the way it does the indexing is by counter, by adding the counter like 0, 1, 2, 3, 4, 5. How many how many the contents are there in that particular list or tuple or whatever set or whatever list tuple dictionary, how many are there, those many counters it will add. I mean count, not counters, this is one counter. Okay, this is the counter. And how many arguments, or how many, not arguments, how many items are there in that particular iterable. For all those items, enumerate will add the indexing, will add the counter. Let us quickly write the program. Okay, so enumerate. I will share this practice.py also on a daily basis. Okay. So yeah, enumerate. Let us quickly write out the list. Okay. Subhash, Chandra, Saira. Okay. List has three items. List has three items. Now enumerate of, not here. The way, let me, yeah, here you have to use the for loop. Key, comma, or I would say, yeah, the index is a key, and val in enumerate of a, then print key, print uh, let me put uh, and val. Okay. So now it is still showing error because I did not close. Okay. So this is how you have to use the enumerate. It requires practice and more programs, more real-time scenarios, all these things. But however, if you would execute, you will get both indexing as well as A is not defined. This is a list, then is okay. So I think it is the same error of previous error. So I think the previous error also it is the same way. We have not I mean the definition should be at the top, right? Hope it is clear now. A is a list that contains Subhash, Chandra, and Sairam. These are the items in the list. And for I am using enumerate. The what the enumerate does, it will add the counter to the items in that particular iterable. Let me write out that here. Hash enumerate will add the counter to the iterable. See, in interviews, you have to use this kind of terminology only if you want to get into. You cannot say, I will. So, generalized definition. Generalized means it is applicable in all time-based circumstances. If you say list, tuple, and all, they will ask another question. Then what about the list? What about tuple? Something. So you should not proceed with the local or circumstantial definition. Rather, you have to use the generalized definition. So enumerate will add counter to the iterable. So for now, what it does, I just use the enumerate in this for loop. I have looped in that, and I have taken key and val. So it returns the indexing for each and every. But I mean, if you take one example, then you don't need this for loop. Depends on how you are writing. For example, b equal to, so print enumerate of b. It will return the address. But I want to see the data type. Then I can do the type conversion, right? Let me see the data type of that particular enumerate. So the data type is an enumerate type, but it is saying list. Okay. Enumerate data type. You can convert it. You can convert it and print it. This is the old concept. I mean, this is already covered in the typecasting and type conversion. So that exactly it has to strike at the right time. So this is the application. Okay, the thing that what we have discussed is application. Unless you apply the programming, you won't be able to master the programming. Like for example, this also, like I have not planned, like I just came just like that to the class without any preparation. However, uh, so if there are multiple items in a particular list, then you are using for loop to for each and every iterable. Okay, and the it enumerate will add the counter, and I have printed 0 1 2 0 1 2 for each iterable. Okay, now without for loop, I mean, why we use it for loop? Because we have not yet come to for loop. For loop, while loop, everything is in next session. So without for loop, I want to write out this enumerate because we have not yet come to that session. Now, yeah, so I just have to take the single list items in the list. I just have to take the single item in the list. Now, when I am printing enumerate, I am getting the enumerate object address, the address at which that is stored, and that contains both the index as well as the value. Then, how do print the contents? You just do the type conversion. You may not know, like, I mean, the enumerate object, you cannot know, I mean, experiment and test it out. You just do the type conversion list. I think you can do other things also. I guess it will work. Let me try it out. See, dictionary 0 Subhash. Okay. It is an enumerate object. The data type itself is enumerate for that particular class object, and it returned 0 Subhash. 0 Subhash, yeah, 0 is the index and Subhash is the value. Okay. Any doubts here?
No, sir, I understood.
Any doubts?
Understood, sir.
Okay, no problem. Now quickly we will cover it out. The we have 1142. Okay, precedence and associativity. This is completely, you already know mathematics, so we will go a little fast pace. For example, A equal to or A plus B minus C. Precedence is something, the Bodmas rule, something which we have gone through in our childhood. Okay. Brackets of division, multiplication, addition, subtraction. This will have high priority. This will have next high priority. This will have next high priority. This is the lowest priority. That is the way we do. This is just for memorization. We did like that. However, addition and subtraction, it will have same precedence. You can add or you can first do the subtraction. It will not make any difference. Whether you do B minus C first, then A plus B, or whether you do first A plus B, then the result you, I mean, subtract the C from that result, both will have the same effect. That is what is precedence. But associativity is something left to right or right to left. That is what is associativity. Okay, left to right or right to left. This is what is associativity. So this one varies. For example, if I have to take some example, so yeah, if I mean, for me also, if I practice more, I can share more examples. Um, yeah, that is how exactly internally it does. For example, into, okay, let me try it out. 2 plus 3 into 4. Okay, now precedence, higher precedence 3 into 4, which is 12. 12. Then it will do 2 plus. Then 2 plus 12 is 14. So associativity, the way how the execution is done, if you observe, it has happened from right to left. It first calculated 3 into 4, then it added to 2, and finally it has become 14. So associativity is the direction in which it calculates. That is what is associativity. Now comes escape sequences. Escape sequences are simple, but I just want to touch upon some high things, some more deeper points like slash n, slash t. These are all called as escape sequences. Okay. Uh, we first of all program. Okay. Print. This is Subhash. Um, okay. Uh, I am um, working founder. I am working with so okay. So when this is called as escape sequences, and if you execute this one, this I am working at Chekora Hub will go to next line. Okay, I am working at Chekora will go to next line. So the few more points. I mean, this you have already good, understood in C language also. But however, this slash n, whenever Python encounters the escape sequences, okay, it will understand that it will, there are various ways, like ideally, this is like printing everything. That is the thing. However, but it encounters, I mean, without slash, if you print, let us understand. Okay, I am Subhash and I am working at Trigger. But whenever you are putting this one, that original behavior, it will change to new line. Please consider the next coming as new line. That is how it interprets. So therefore, this slash and slash t, these these the point is, this escapes the original behavior and new behavior is adding new line. That is it will add the new behavior. That is how the term itself came from escape sequencing. That means the original behavior of uh, printing a line, you escape that behavior, don't print, and use this as new line. For this particular slash and go for new line. This is new tab. Okay, tab. Slash t means it will take one tab delimited. Okay, it has taken the tab delimiter. So that is escape sequences. Okay. Now comes ASCII and Unicode. These are actually, you may not get this in interview questions. However, ASCII can range up to 128 only. Okay, first let us understand the ASCII. For each and every number, because the computer cannot understand ABC everything, it will only understand ones and zeros. For each and every uh, character, or in your keyboard you have dollar, all these things. For each and everything, you will have an ASCII value. I mean, I don't know the ASCII value for dollar, but let me try print r dot a. For a, we know that is 65. I mean, I know as part of remembering. ASCII value of a is 65. ORD is the built-in function to know the ASCII value. Okay, ASCII, ASCII value of a is. We will try out dollar because for my learning. As far as I know, all the keyboard, whatever there in the keyboard, for all these things, there will be one ASCII value. So the ASCII value of A is 65. For dollar, will it be there? Should be there. Yeah, for dollar, the ASCII value is 36. Okay. Now, the way how these ASCII values are calculated, because we have two bits, 0 and 1. Okay, we have two bits, 0 and 1. Now, this ASCII can have 7. 1, 2, 3, 4, 5, 6, 7. Okay, so 2 power 7 equal to 128. All these are background calculation not required. So whatever there in our keyboard, small letters, uppercase, lowercase, 1, 2, 3, so all these things will have an ASCII value, and internally that conversion happens. Like for example, for A it is 65. Okay, 65 means you put like this something and you calculate 2 power 0 into 1 plus 2 power 1 into 1 into 1 and finally you will get 65. However, for the Unicode, it is little more. The Unicode came to whatever, whatever I would say not defects, limitations, whatever limitations that are there for ASCII, to cover those limitations, this Unicode has come. So Unicode can have up to 2 power 32, I think, and 2 power 32, I do not know, uh, some big number. Okay, it like all your emojis, like most of you smileys, all these things we will put in WhatsApp and all. But that is the Unicode conversion. Internally, the computer does the conversion and it will print one smiley. Okay, or rocket symbols, all these things. So these are these concepts. Yeah, any doubts you can pause and ask. Now this is a quick pointers. Python identifier. So when I mean why I have mentioned this point, because whenever you are running the programs, you will get certain errors. Okay, you will get some kind of errors, identifier mismatch or something like that. Then you don't be worried. Identifier is something like naming a particular element in the Python, in the programming. That's all. Whether it can be class, whether it can be object, whether it can be a whether it can be dictionary, tuple, list, integer, whatever it is. That is uh, it is just for calling purposes. Okay. However, but it can be some variable only, like for example, integer variable. But Python doesn't say in your errors integer mismatch. It will not say like that. Like I mean, why it has to. That is your problem. So it will say some identifier, some kind of errors will come. So at that time, you don't need to get confused. Identifier is something. It is um, it is for calling that particular element. Okay, just naming the element. Remember like that. So identifier means name, calling an element with that name, calling or naming an element, calling name or element in programming. For element in programming, there are so many elements are there, class, all these things are there. So for calling purposes, we call that as identifier. That's it. Okay, it will help in case of programming, execution, all these things. So then comes if these jumping statements and control flow, we will both are same. Jumping statements, you can like control flow is nothing but break, continue, all these things. So this all we will cover in next class, session 4. We will cover looping, for loop, while loop, all these things. And we will also cover control break, okay, and also functions. And then probably I will also start the loops, I guess. I will see whether loops or whether, yeah, not immediately loops. We will start out the various methods in list all these things. So break and continue, all these things are control flow statements, but they you can also call them as jumping statements, because in particular programming you can jump from that particular place to different place, like from acha, I am writing okay, but nobody interrupted me, no issue. So this is Python identifier. Python identifier is for element in programming. Then what about this one? ASCII. This one also you did not see, right? Bhuvan, can you please confirm when I am explaining ASCII and Unicode? Are you seeing my iPad?
Yeah, I have seen the code, sir. Code of the ASCII. Like in VS Code, I have seen the code,
Okay.
sir. That's it only.
Is he there?
Sir,
I mean, is my Visual Studio I am sharing or
yeah, yeah,
iPad
sir.
screen? Which one I am sharing when I am explaining this ASCII and Unicode?
Now I am visible from iPad screen also, sir. No, I can able to see iPad screen
Can
also.
anybody respond? Okay, no issue. Already late. Amount. Okay, Bhuvan, you are saying something probably I am not able to hear.
Sir, I can able to see both
Yeah, you are
screens, sir.
speaking, but I am not able to hear. Okay, no issue. I will quickly cover it out from here. So, escape sequencing means this one I have written here, right? ASCII. Okay, ASCII also I have written. So, yeah, for Unicode it is yeah, ASCII 2 power 7. It will store like this. For all the keys in the keyboard, the for all the keys in the keyboard, there will be an ASCII value which the computer internally converts and it will processes, the CPU processes, and Unicode, whatever limitations that are there in the ASCII, the Unicode will to fill that particular gap. The Unicode later came and it can store up to 2 power 32. You can calculate, but it is 32 bits, this much like this it will come. Okay, so 2 power 32. All the emojis, whatever I have explained, these will be all the Unicode. Now here identifier is nothing but in your programming you will get this kind of errors, identifier mismatch something. So there identifier is nothing but it is an element in programming. You are calling by that name. Then jumping statements, control statements, both are same. Break, continue. These can you can also call them as jumping statements, because in a particular program you can jump from 65th line to 700 line using these control statements. So they are also called as jumping statements. So collections, arbitrary arguments packing, I explained. Labeled, I explained. Collections. So list, these are all collections. List, tuple, all these are collections. So I think we are done.